Slope. Let's talk about slope. Slope refers to the steepness of a line, and also to the direction. So, let's consider this line right here. Now, all slope is, it's a ratio of movement. You're only allowed to go up and down and left and right. So if we were to start from this point and go up and then over, this ratio of this vertical change over this horizontal change is a slope. And it's consistent throughout the line. Up, over. Now my graph isn't drawn to scale, but this is just to give you an idea of what's going on. In the same turn, I could take the slope and go rise, and then go over the right, up, over, up, over. Now those right there would be actual points on the line. Let's just give you an idea of slope. Something else about slope. Think about a plane. A plane taking off. If a plane takes off in the upward direction, that means that we have a positive slope. If the plane is landing, coming down in downward direction, that means we have a negative slope. A plane can also run horizontally. And what that means is it hasn't gone up or down, it's staying at ground level, which means it's staying at 0. And then a final example to look at is, think about a plane. Most planes, let's say all planes for this situation, you cannot go straight up. They need to take off before they go, they need to start moving horizontally before they can take off. So since we have a plane that we're going to say that can't go straight up, that means it's not possible. What we use for not possible is undefined. So, to summarize, if we have a line that goes up, it's positive slope. If the line goes down, it's negative. Horizontal lines have a slope of 0, and vertical lines have an undefined slope. Now, an example that we could use to explain slope involves slope formula. And we're going to use this example to create or to demonstrate how this formula comes about. Now, a lot of people know slope as rise over run. And all rise over run means, if you think about it, on the x-axis and the y-axis, it's the y's that rise and it's the x's that run. That's why it's called rise over run. It's the ratio of y's, difference in y's, over the ratio and the difference of x's. Some books say it's the change in y's divided by the change in x's. Anytime you see the letter M, it's always used to designate slope in the algebra class, no matter what. M is always slope. Now I'm going to use this formula with a diagram to show you where slope comes from. In fact, I'm going to do a little bit easier one just to help you out a little bit. We're going to find the slope between these 2 points, 2, 3 and 7, 18. Now I'm going to draw the line. I'm only going to do this once, then I'm going to show you the value of a formula. Now 2, 3 will be about right there. And then 18 will be about right there, 7 will be about right there. So we'll call that 7, 18, and this is 2, 3. Now we're going to connect the dots. And we're going to show you where this formula comes from. Now remember, all slope is rise over run, vertical change divided by the horizontal change. So let's say I start at this point right here. I'm only allowed to go straight up. So if I go straight up, how many places did I move? Well, if you look at it, we're at a 3, and we went all the way up to an 18. That tells me that that's a difference of 15. Now if we run to the right, and by the way, since we went up, that's a positive 15. Now if we go to the right from here to there, what that's saying is we started from a 2 and we ended up at 7. So from 2 to 7, the difference is 5. And since we went to the right, that's a positive 5. So if you think of slope as rise over run, our rise was a positive 15 over positive 5, which reduces down to plus 3 over plus 1, which is the same as positive 3. Notice the line is going up from left to right. It's always a positive value. Now we don't have to draw this picture over and over again. Before I mention what I was going to mention, we also could have went from this point and went down first, and if we did, that'd been a negative 15, and then we could have went to the left, which is a negative 5, and we still get the same answer. Negative 15 over negative 5 is still equal to positive 3. So it does not matter which way you go, but the signs represent the direction, which is very important. Now, this formula right here simplifies the work as far as not having to draw pictures. Because if you look, all we did to find the 15, we just went this 18 y value and subtracted the 3y value. And to get this x value of plus 5, all we did was subtract the x values. And we just went 7 minus 2. And that's what this formula does. It makes it a little bit easier for us without having to draw pictures continuously. So now let's do a few examples, and we'll use this formula. And I'll show you how I use this formula to help avoid sound mistakes. What I do is, I am going to use the slope formula. And when I write it out, I don't even look at the numbers. This is my first step. I always write the formula with empty parentheses, and those parentheses represent the x's and the y's. Now, it does not matter which one you call y2, y1, and by the way, this y1, y2, the reason why we have those subscripts is because all points are the form of x comma y. We don't want to start changing variables like a comma b and c comma d. It's always best to use x's and y's. These ones mean this is our first point, and these twos mean this is our second point. It does not matter which one you call which, but you gotta stay consistent. So if I call this the next one, this must be y1. Now if that were x1, then that would have to be y1. But since I've already got x1 and y1 labeled, that means that this has to be x2, y2. It's a big deal not to mix and match. And so, since the formula says we just take our y values and subtract them, what I'm going to do is take the y values, negative 7 and negative 8, and put them in parentheses. Now, since I put negative 7 first on top, I must put the negative 2 first on the bottom. If I don't, it's going to change the sign. Instead of having a line going up, I'm going to have a line going down. It's a big deal in real life situations. Instead of you thinking you're making money, you might actually be losing money. It's a big, big deal. And so, since I got negative 2 there, I got to put the 1 here for x2 minus x1, and then we just do it algebraically. Negative 7 minus negative 8, same thing as negative 7 plus 8, which is a positive 1. Negative 2 minus 3 is negative 3. What that means is our line will be going down. Let's do this example. I'm going to do it the same way. What I'll show is the safest way to do any of these problems while avoiding mistakes. Just to change it up a little bit, just to prove to you it doesn't matter. Let's just say that I wasn't paying much attention to the numbers and I just threw in a 4. If I put the 4 there, then I must put the negative 3 there. Now, since I start with the 4 here, I must put the 3 first down there, and then the 9. In other words, this 3 comma 4 lines up vertically. 9 comma negative 3 lines up vertically. Has to. 4 minus the negative 3 is a 7. 3 minus 9 is negative 6. Does not matter what the minus sign is, it's still negative. Now look at this next example. Y equals negative 4. What I'm going to do with this situation, with this example, I'm going to use a little T-chart to help with some points. And then we're going to start making some conclusions. X, we can use anything. Let's use 0 and 1. But Y must be negative 4. Because when anytime you have an equation that says Y equals negative 4, Y is always negative 4. So once again, I'm going to use the slope formula. It's just Y's over X's. I'm going to put negative 4 minus negative 4, and then 1 minus 0. Anything subtracted from itself is always 0, and 1 minus 0 is 0. And if you remember my horizontal example, horizontal lines, that's what Y equals negative 4 is. It's a horizontal line. Slope is always 0. Oh, keep that in mind. Anytime you have a horizontal line, the slope is always 0. It's not going up or down. It's staying at 0 ground level. Now for x equals 3, we're going to do the same thing. Use a little t-chart. X has to be 3 no matter what. Because when it says x equals 3, that's what it means. X is always 3. Y could be 0 or 1, or whatever number you want to use. I'm going to use the easiest numbers. Going to use the slope formula again. We'll put the y's on top. X is on the bottom. And we get 1 over 0, and a lot of people miss this problem. They even miss it in calculus. Division by 0 is impossible. You can use a circle with a line through it, or just say undefined. And if you remember my plane example, x equals 3 is a vertical line. What that means is we can't, a plane normally, most planes cannot go straight up. They gotta take off first horizontally before they can take off in the air. So anytime you have a vertical line, slope is always undefined. And that's what this summary is. Slopes of horizontal lines are always 0, and slopes of vertical lines are undefined. Big deal. It never ever goes away. Now let's look at the slope-intercept equations of lines. Now, this is probably one of the most useful equations of lines that we can use. Y equals mx plus b. And the way I like to explain this is very simple to understand. And when I do this, it tends to make life a little bit easier for people. Now y, all y is, it's nothing but a letter of the alphabet. Even though it's not what it really is, but that's how you want to think of it. Like I said, anytime you see an M, it's always slope. Guess what x is? It's a letter of the alphabet. Now b is actually the y value of the y-intercept. Now, some people say it's actually the y-intercept. It's actually not. It's actually the y value of the y-intercept. The y-intercept is always 0, comma, some value. In this case, it's b. Now all this equation means, it just means solve for y. When you solve for y, you're going to find the slope. Because if you look, anytime it's y equals, the number in front of the x variable is always a slope. Keep that in mind. So for this example, when it says find the slope, you notice it's already in the form y equals mx plus b, which means it's already solved for y. It's already y equals. If you want to, you can write down y equals mx plus b. And notice slope is in front of the x, which tells me that slope is 7. Now this one, we cannot say the slope is 2. A lot of people do that, but you can't. It's not solved for y. So we're going to solve for y. And when we do, we're going to have it in the correct form. This is just a 2-step problem. When you solve for y, you want to eliminate the x term to get the y term by itself. And you do the opposite. Well, the opposite of positive 2x and negative 2x, which just means subtract 2x. And you end up with the negative 8y on the left side, because those essentially cancel out. And then over here you have 5 minus 2x, but those aren't like terms. So that means you keep them as they are. I like to write the x term first. Now, on this one, we still don't have y by itself, but we will as soon as we divide by negative 8. Now here's what you want to do to make sure that you don't make any mistakes, common mistakes. When you come over here and divide by negative 8, I highly recommend dividing each of those by negative 8. And when you do that, you're going to have a y equals, and negative 2 divided by negative 4 becomes a positive 1/4 x, and plus 5 divided by negative 8 is a negative 5/8. Now that it's y equals, the slope was always in front of the x, so it's 1/4. Keep that little trick in mind right there. It's not a trick, it's just a good guideline to follow. Now the last example is just an application of slope and its grade. All grade is the same as slope as a percentage. Anytime you're given a picture like this, think of rise over run. So if the rise is 8, run is 15 feet. pretty much all you're doing as far as finding the slope. Now to find the grade, you want to take out a calculator and divide 8 by 15, and you're going to get 0.533, and it keeps on going around to the nearest tenths in their percent form. When you move the decimal 2 places, you're going to have 53.3%.